Okay, truth tables for negation, conjunction, and disjunction. This is the topic we're going to cover in this section. Before this section, we did talk about statements, negations, and quantified statement, and compound statements and connectives. So today we're going to create truth tables. So these are the objective. Use the definitions of negation, conjunction, and disjunction, and then construct truth tables. Determine the truth value of a compound statement for a specific case. So truth tables, this is an example of truth table. For example, let's say you have a statement P, and then its negation is this negation of P. So if the statement P is true, then its negation is supposed to be false. If the statement itself is false, then negation of that would be true. So this information in this table is called truth table, and this is for negation, not opposite truth value from the statement. And this is the truth table for conjunction. Conjunction means P and Q. These are the two statements, and then you compound them, you combine them. And if both of them are true and true, then true and true becomes true. If one is true and another one is false, true statement and false statement gives you the false, because to be the and means if both of them are true, then that's true. Otherwise, if even one of them is false, then the conjunction gives you false. I'm going to give you example, but this is the for example, let's say one of the statement is the pen is red, and then another statement is it's 9 a.m. So if the pen is red, if that is true, and then if it's 9 a.m., then conjunction, the pen is red and it's 9 a.m. supposed to be true. But let's say one of them is false, like for example, it's not 9 a.m., it's a 10 a.m., then the pen is red and it's 9 a.m. statement supposed to be false. You understand? So whenever you combine, that's supposed to give you the final statement. Disjunction, we do the same thing, but this time instead of and, we're using or. If one of the statement is false and one of the statement is true, then or statements, this condition, when you try to combine, that's supposed to be true. If both of them are false, then that's supposed to be false. I'm going to give you example later. Okay, so this is a truth table. Let's look at some examples. Fill in the blank so that the resulting statement is true. Negation of P has opposite truth value from P, because negation means it's opposite. A conjunction P and Q is true only both of them are true. This is the, if both of them are true, then only the conjunction would be true. The disjunction, a disjunction P or Q is false when, look at here, this is the disjunction, and this is false when both of them are false. Okay, let's say you have a statement, Q is a statement 6 times 10 is 60. That's a true statement. What is the negation of Q? Negation of Q is supposed to be false, because the statement itself is true. Let's say there are two statements P and Q. 7 plus 10 is 17. That's a true statement. 3 times 8 is 24. That is also true. Both of them are true. Because both of them are true, then P and Q, both of them are true, so it's supposed to be true. How do you say it? 7 plus 10 is 17 and 3 times 8 is 24. That is the meaning of this. Let's create the truth table for this one. you have two statement Q and then its negation. If Q is true, then negation is supposed to be false. If Q is false, then negation means opposite is true. Now we are taking AND. If Q and opposite of Q, if any of them is false, then it's supposed to be false from truth table of conjunction. The conjunction AND statement would be only true if both of them are false. Both of them are true. Otherwise, in all other cases, it's supposed to be false. Okay, let's do this one. We would like to create this table, truth table. Let's say P and Q, and these are the situation. If P is true and Q is true, the negation of Q is false. And then now you are trying to find out or P and this one. So if one of them is true, then that's supposed to be true. Okay. And negation of this statement, if this is true, then negation is false. You understand? Because we are trying to find the negation of this statement. Okay. Now, if Q is false, then negation of Q is true. And if both of them are true, then OR is also true. True or true is true, of course. And what is the negation of true? It's supposed to be false. This last column is the negation of the third column. Okay. If Q is true, then negation of Q is false. And if both of them are false, then false or false is also false. And the negation of false is true. False, negation of false is true. If one of them is true, then it's supposed to be true. If this is true, then its negation is false. Okay. Refer to the following statement to answer part A through C. You did not do the laundry and you left the garage a mess. These are the two statements. We are connecting them with the AND. So how can you write it? So P means you did not do the laundry and Q means you left the garage mess. But this means, okay, you did the laundry and you left the garage mess. Not P means you did not do the laundry and you left the R. This is R. The only AND you can see is B and C. So the answer is supposed to be either B or C. Let's read B. P is you did the laundry and Q is you left the garage mess. So negation of P is you did not do the laundry. So this is the right answer. So you have to find the right symbol and then out of those symbols, you need to find out the right statement. Construct a truth table for the symbolic statement in part A. If P, which is you did the laundry, is true and you left the garage mess, then opposite of you did the laundry would be false. That means you did not do the laundry. And then AND of this and Q would be true and false is false. If one of them is false, then AND statement always gives you the false. So you did not do the laundry and you left garage a mess. That is false. What is opposite of P? What is negation of P? It's a false because P is truth. And then what is the AND of negation of P and Q? False and false is definitely false. False, the negation of false is truth, and then truth and truth is definitely truth. If both of them are true, then AND operation always ends up with the truth statement. So opposite of false is true, true and false is false. Okay, use the truth table to indicate one set of conditions that make the compound statement true, or state that no such condition exists. Look at here. This is where the compound statement is true. When the P is false and Q is true, right? So the statement is true when P is false and Q is true. This is where it's true. Let me do maybe this one. Determine the truth value for the statement below when P is false and Q is false. When P is false and Q is false and R is true. Okay, so first of all, always do the operation inside the parenthesis. If Q is false and R is false, true, then false and true gives you false. And P is false, false or false is still false. The statement is false. Okay, and that's all for this section. Okay, so P implies not Q, which is P is false, implies truth, that is true. Okay, and then not P, which is true, implies Q, which is false, that is false. And then truth and false is false. Okay, there is something wrong here. What did I do wrong? Okay, let's go back here. True and true, false and false. So P implies not Q, that means truth implies false. Truth implies false, so that means it's a false. And then not true means false implies truth, false implies truth, that is true. And then false and truth is false. Similarly, false and truth, so P, which is truth, implies not Q, truth, so that means true. And then not P, which is false, implies truth, implies truth, that is truth. False implies false, that is also true. True and true is also true. Again, not P is truth, and then not Q is false. So here false implies false, that is true. And then truth implies truth, that is also true. So true and true is true. Finally, false implies truth, which is true. And false implies true. False implies true. Okay. False, which is not P, is a P is a false. False implies true, which is true. And then truth implies false, which is false. So truth and false is false. I am not so sure what is wrong here. Okay, let me check. Okay, after trying this problem 3 times, I did not get any different answer. So finally, when I check the answer, my answer, which is this one, is exactly as the answer it's supposed to be. So the system, this MyLab, is wrong. If you can compare here, everything else, they are same, exactly same. But for some reason, the system working, it's not working, and then it's not recognizing my answer. I don't know, but I see everything else is right. So the process is right. Let's go to the next step. The next step is, what are the conditions that make the compound statement false? So the two conditions where compound statements are false, where both of them are either true or false. So the statement is false when P and Q have the same truth value. Look at here. If P and Q have the same truth value, the compound statement, both of them, they are false. Okay, that's all for this section.